Hey everyone, I'd love to talk today about something that I've been super passionate about working for Fulcra for the last several months, and that is helping someone understand how they could get better sleep by doing data science on their data. My name is Ajay, and I'm someone that's really interested in doing time series data analysis in human data. So the central question that I had been tasked to answer is, is it possible to figure out what lifestyle changes would result in a Fulcra user increasing the night of sleep that they could get per night, given the access to all of these data sets? Or is it even possible to figure out how to get better sleep? To put a really long story short, yes, it is possible. And the answer turns out, to just change the timing of the last meal that the person had per day. And if they did so, if they just changed the time at the end of the day that they had their last meal, they could increase their sleep by potentially 1 to 2 hours. Pretty cool, right? Now you'd think that by looking through that this is something that you could just easily do by taking all this data, putting it into an LLM, and then using the LLM to give you the answer. Well, it turns out you can't do that. And that's because the scale of the time data that we're working on, the 6 months worth of data from devices like the Oura Ring, the Levels continuous glucose monitor, Apple Watch, it represents around 16 million tokens. And fortunately, what Fulcra has done, which I think is absolutely brilliant, is that they've found a way to make an API call that feeds into a pandas data frame, which is great for data scientists because then you can start doing things like traditional data science on this data. And in particular, the two data APIs that were really useful for me to actually go about doing the analysis I wanted to do were the Fulcra location time series data and this Fulcra metric time series API endpoint. And the cool thing about that is that you can capture at almost a rate of 1 data point per second time resolution for almost all the data points that I had just talked to you about. And then the other question isn't just about the data itself, it's about the relationship between the data and the lifestyle. So to go back to the question was, well, what lifestyle changes would result in a Fulcra user increasing the amount of sleep that they could get per night? Now, if you think about the way your devices measure data and how they record it, they record data to this so from the start of the day to the end of the day, so they record it by time. In order to do this analysis, I had to rethink the relationship between time itself and how the devices measure time and how you perceive time as a result of you going about your day. So what I did is I figured out a way to group data that comes from the wake part of your day and associate it to the sleep part of your day. And what that did is it enabled me to remove these time boundaries and understand time at a body level. And then what I did is I grouped data itself, and I said, look, if you had a great sleep or a bad sleep, let's just group all that data into a classification system, and then let's group all the other data that I've been collecting on this user, and ask the question that, given a day where they had either great sleep or bad sleep, what was the day after? Or what was the day before? So I looked at both of these ways and I tried to figure out what was the relationship between the wake that happened the day before and then the night that happened afterwards. So a little bit of thinking through the time element of this itself. I actually found something pretty interesting. I found that on both days that the user had great sleep, the day before, there was some differences in the caloric rate intake as well as the blood glucose. And that was also true for the days that had poor deep sleep. I did look into the field of chronobiology, and what I found was that there's actually a lot of literature about chronobiology and the relationship between your body clock and the things that happen within your body and the surrounding environment that does influence your sleep. And actually, one of the people that really coined this entire field, Jürgen Aschoff, found out that there are these things called photic and non-photic cues. Cues like light, which we all understand, whether you're sitting on your phone late at night at like 11 o'clock and taking a look at your phone, it does impact your sleep. But also things like your eating and drinking patterns, your exercise, your social interactions, all of these things impact your sleep. And what's interesting is that the eating and drinking patterns that came out through the blood glucose changes that I saw through this person's data were also on this list. And of course, one of the things that is powerful to look at now that we have access to all this data is that we can see whether or not someone is going through entrainment, which is the behaviors that they're doing are impacting their sleep, because we have the ability now to look through devices and do data science on their data because of Fulcra and get to this answer, where it used to be things that you'd have to enroll into a clinical trial or some sort of study in order to get some answer about, or look at other organisms like mice and rats. But with Fulcra, we can now just look at us individually and see if we're going through some form of entrainment exercise because of our behaviors, like exercise or feeding patterns, or even the temperature or the time of light that we expose our bodies to. One of the requirements that thankfully, was met was that I found that through this continuous glucose monitoring solution that the user was wearing, I found that there was a passive, that I could glean his passive glucose consumption rate. And because of that, I could glean also the time of his meals, as well as correlated to the day and night that I had already figured out because of his sleeping habits. And fortunately, there is a direct way in Fulcra Stack to actually measure the blood glucose if you are wearing a blood glucose monitor. So all I did is I just took that data and I resolved it using Fulcra's API. And what I found, is that for the times of sleep where there's this effect where you have cortisol-induced glucose increase, and then of course the meals that you take, I just found out the latest spike, which is from the last point of the day that the person was awake. What was the point that they had their last meal? And I just took that data and I figured out that, hey, look at this. It turns out that the days where the person had the more sleep were the days that, the last spike in glucose consumption, which is the time of the last meal of the day, happened to be earlier. But all of this kind of comes to a head about sort of the broader role of Fulcra, which I think is quite interesting. We seem to be in an era where semi-invasive continuous measurement and monitoring are rapidly becoming the norm, right? We want to do self-evaluation, we want to do self-experimentation for higher self-understanding, and that used to be a distant concept, but it's becoming increasingly more feasible. But if you think of all the devices that you might own, at the moment most of them are siloed. They're just, your Apple Watch will have Apple healthcare data, but maybe not your glucose data. And then if you've got a sleep aid mattress, then how does that data get into this one place? And then of course, where do you even do all your data analysis? That's also another question. From an analysis like this, the things that we have to do are leverage the decades of research in biological time series data and multi-scale systems to understand how can we do something as simple as analyze sleep. Because if you don't, and you just try to put a sort of a naive machine learning classifier on this data, the data itself becomes too unwieldy, too temporally dense, and too complicated to generate meaningful insights. But if you put it all together, put a touch of biology, put a touch of easy access to data, and then data science, you can start to unlock this data. And in doing so, I'm looking forward to is one where, through the de-siloing and harmonizing of all this wearable data, we can empower citizen scientists like myself, and data-curious individuals maybe like yourself, to explore yours or maybe your friends' or clients' health data in greater depth. We can build things like compelling arguments about our health status. And I think that if we collect this data, de-silo it, harmonize it, make it available for data scientists to use, or maybe even build tools upon that, we can do things like, improve people's outcomes in health, or maybe even enable biohacking or self-experimentation, and give ourselves the ability to actually enable a better holistic sense of well-being. And that's what really excites me about this analysis. I think directionally what this enables is people to get a better sense of who they are and what's actually going on in their lives that they can meaningfully ask questions to if they're curious. So anyways, that's a long-winded way of saying I really appreciate anyone listening to this, and thanks.